finishing off this course is that we have these two questions. Now we're getting to integrals. So it's asking to evaluate the integral. So you could see this, that we have the magnitude right here. So let's find that first before integrating this function. So you could see it as r of t, which just equals to ti plus t squared and j, and finding the magnitude of that, we just get t squared plus t squared squared. So that would just give us t squared plus t to the fourth. So that's the magnitude. But we can factor out the t squared, so we get this. T of 1 plus t squared. So we get that. So let's find the integral. So we get this of 0 of t of 1 plus t squared dt. So we can split them off. So to solve this integral, we can use a substitution method. So we get u equals 1 plus t squared for this. And du just would equal to 2t dt, which makes, we could convert that into t dt, which equals to 1/2 du. So when we do that, when t equals 0, u equals 1, right? When t equals 0, u equals 1. And when t equals 3, we get u equals 1 plus 3 squared. So that just equals 10. So now we could rewrite the integral as t 1 plus 2t dt as 10 1 square root of 0 square root of u times 1/2 du. So this basically simplifies. This is a constant right here. This could be simplified as 1/2 of 10 1 of u to the 1/2 power du, right? So now we integrate, right? So we just get 1/2 of u to 3 here and 3 here, 3 over 2 here of 10 1. So that would just equals to 1/2 times 2/3 of u 3t, right? And that would just equals to 1/3 of u 3 over 2 power 10 1. So now we could evaluate the bounds. So you got 1/3 of 10 to the power of 3 over 2 minus 1 of the power of 3 over 2, right? Now that would just equals to 1/3 of 10 to the square root of 10 minus 1, right? So that's our final answer of 1/3 10 square root of 10 minus 1. And that's how you would evaluate this integral. So now let's get to the final integral, right? So we have to evaluate this integral, right, where the r of t is equals to this, right? We need to integrate each component of the vector valued function separately, right? So that would just, look like, let me write the definition down. 0 of r of t dt, which just equals to 1, 0 for the x, y, and z components, right? So we separate them. So let me just write it here so you can visualize it. 1 over t plus 1 and e to the negative t. That would just look like we separate all of them. 1, 0, 3 t dt, right? 1 over t plus 1 dt. Then we have finally e to the negative t dt, right? So we do this separately, right? So first things first, let's solve this integral, right? So we have this 1 over 0, 3t dt, which just equals to 1, 0, t to 1/3 power dt, right? So using the power rule for integration, right, that would just equals t to the 1/3 power, right, plus 1, and we have the same thing here as the denominator. That would just equals to t to the 4 over 3, 4 over 3, right? So we could just visualize as this, 3/4 t to the 4th power, right? So now we would just evaluate it from 0 to 1, right? So we have 3/4 of 1, right? 4 over 3 minus 0, 4 over power 4 over 3, right? That would just equal 3/4. So the first answer is 3/4. Let's write it here. Now let's keep on going. Now we have to integrate 1 over t plus 1, right? So this is a logarithmic integral. So that would just, if you know this, that would just be equals to L of n of t plus 1, right? So now we could just integrate that with bounds of 1, 0, right? So we have L of n of 1, right, plus 1 minus L of n of 0 plus 1. So that would just equals to ln of 2 minus ln of 1, right? That would just equals ln of 2. So now we have this as an answer. Oh, I did the wrong one. 3/4 and ln of 2. Now we just do this final integral, right? So integrating this one, right? T, the antiderivative is not like you can't do anything to it. So for e power of negative t, right? That's the antiderivative. So now we just evaluate this from 0 to 1, right? So 1 to 0. That would just equals to negative e to the power of 1 minus negative e to the power of 0, right? So that would just equals to negative 1 over e plus 1. So that would just equals 1 minus 1 over e, right? So combining everything, right? 1 minus 1 over e, we have the answer for this integral is 3/4 I ln of 2j and 1 minus 1 over e k. So yay.